A worker wishes to pile a cone of sand into a circular area in his yard. The radius of the circle is r and no sand is to be split to the surrounding. If mu is the coefficient of the static friction, we have to calculate the maximum volume till which the sand can be piled. It means that suppose there is a first layer of sand which forms a cone somewhat like this. On this layer he puts on a layer on top, okay, he puts a layer on top, and that's how a cone is formed of radius r, okay, radius is r over here and the height is h in this case, okay. We have to calculate the maximum volume in terms of r, so in short we have to calculate the value of h. So basically if I take any layer of sand, let us consider that I take this layer of sand. Suppose m amount of sand is above it, okay. So now what are the forces acting on it? mg in the downward direction, okay, normal force in this direction. Now if there is no friction, it will slide down, so the friction force should be in the upward direction to hold it together. So basically the friction force should be equal to friction force, that is the force acting in the above the slope, should be equal to mg sin theta, which is the force acting below the slope, okay. So basically f should be equal to mg sin theta, whatever may be the mass, okay, whatever may be the mass, the friction force is equal to mu mg cos theta. So basically we get a general formula for we get the standard formula for the mu, that is mu is equal to tan theta, okay, mu is equal to tan theta. Now tan theta will be the theta over here, the theta over here is this angle, take any angle over here, okay. If I take an angle over here, this angle will be equal to theta, okay. Now theta, if you consider, it will be equal to h by r. So tan theta will be equal to h divided by r. Now the volume is equal to 1 by 3, volume of cone is equal to pi r square h. Now instead of pi r square h, instead of h I will substitute r into mu, okay. So when I substitute r into mu, it will be equal to 1 by 3 pi mu into r square is already present into r. So it will be equal to 1 by 3 pi mu r cube, okay. This will be the maximum volume of the cone till which the sand will not fall or the structure will remain as it is.